everybody, and welcome to the first Educator Network meeting of 2022, which is incredible. I'm reliably informed this is the 9th of these sessions that we've had, so spanning all of 2021 and now into 2022, which is incredible, and still getting a good attendance at these from across the world, which is fantastic. So thanks for giving up your time. We'll kind of press on because we, as usual, have lots and lots to get through in the next hour. For those of you that don't know who I am, I'm Professor Steve Tucker from the University of Aberdeen, and I'm the current Vice President for Academic Development at the BPS, and I'll be chairing the session this afternoon. Just before we launch fully into everything, I'd just like to thank Lee Page at the BPS for all his work in putting this together, for setting up the registration pages, for pulling together the various bits and pieces that allow these sessions to run like clockwork. And also thanks to the facilitators for the second half of the session, Aidan, Christine and Susan. So for the first half of the session, we're going to have a talk from Dr. Paul Mitchell, who's a senior lecturer at the University of Bath. And Paul's going to talk to us about statistics and experimental design. And what we'll do, as always, to save interrupting Paul, is we'll save the questions for once he's finished his talk, and we can have a discussion about those before we move into the breakout sessions in the second half hour. So over to Paul. Thank you very much, Paul, and very much look forward to hearing your talk.
Thanks, Steve, and my thanks as well to both Steve and Lee for inviting me to give this talk this afternoon. Bear with me, I need to sort of share my screen so that I can show you exactly. Hopefully you can see a blue screen at the moment. And now with luck, you should be able to see my title slide. Is that okay? Can you see that? I can't see anything. No.
Just try that share screen again, Paul. I think perhaps you didn't quite click the button.
Let me come out of the. Hang on. How's that?
It looks like it's starting now. Yeah.
That's better.
Yeah, we got it now, Paul.
Right,
yeah.
Thanks a lot. Cheers, guys. So you should be able to see title slide. Is that okay? Yes.
Yeah, I can see that.
Okay, so this short talk is really simply an introduction based on my experiences from teaching statistics at undergraduate level for over 20 years now. I think what I should say is that, I want to try and put across some of the lessons that we've learned over that period of time and some of the developments that we've initiated in the way in which we teach statistics and experimental design. This is not meant as a guide to how you should actually teach statistics. It's not a list of do's and don'ts and what you need to teach or what you need to include or omit. Neither is it a recommendation on which statistical software to use, because that could easily depend upon the institution where you're working. And nor is it a critique of the interpretation or perhaps misinterpretation of probability values generated by different inferential tests. So now that I've set those sort of ground rules, if you like, I just want to look at pharmacology undergraduate programs, the core curriculum by the BPS. And I want to highlight just a few areas. First of all, statistical analysis is really part of the methodological principles. It's part of the tools and it informs our scientific method. And it's key that this is actually part of the core curriculum. But likewise, statistics is also part of the experimental techniques that we need to teach our students. So we need to be able to teach them how to formulate scientific hypotheses, a good experimental planning and design, what the correct statistical approach might be, and how to make decisions about the methodology, and so on and so forth. Students need to be able to critically evaluate data. And if we don't teach them the statistical techniques to start off with, they're not going to be able to do this. And likewise, they need to interpret statistical tests correctly. And finally, they need to be able to use common statistical software packages. And there are some subtle differences between different packages that are available at the moment. Statistics, to my mind, is a core skill in pharmacology education. As a tool, we need to know how to use statistics, and therefore we need the skills to actually use it. Pharmacologists, and I include myself here, we don't claim to be statisticians, but we do need to know how to use statistics to analyze our experimental data in order to understand how changes in whatever the experimental output may be, how they are related to the real world. And that's an important consideration. So we really need to focus in our education on the application of statistics to real data. And I also need to extend this in a way to studying the study of life sciences and the biomedical sciences as well. It's not just part of pharmacology, but is across the biological science. And I think one final thing to say is that the role that statistics plays should also be fully integrated into the teaching of the principles of robust experimental design. The two go hand in hand. And one important consideration of this is that when you're designing experiments, you must decide on your statistical strategy before you actually perform the experiment. Too often I get students banging on my door with their hands clasping a whole ream full of data and ask me, how do I analyze this data? That is the wrong time to ask that kind of question. And students should be encouraged to think about the statistical techniques they're going to use at the design stage of their experiments. And hopefully that will then continue on into the rest of their career. As far as statistics teaching at Bath is concerned, well, pharmacology undergraduate programs started back in the early 1970s. And over the following 30 years, then really all we used here at Bath were some ad hoc tutorials with a limited lecture provisions provided by the maths department. And these were, from our experience, delivered to the pharmacy and pharmacology undergraduate students. We also had a supporting in-house booklet, but this was not of any sort of commercial level. This created problems. It created problems because the engagement of the student population was very poor. The maths department found it difficult to base the lectures upon what the students actually needed. And the result of this was that students rapidly forgot the subject material in those lectures. By the year 2000, which is sort of after I came back to the university, we generated a series of 3 two-hour workshops. And this was really all we gave to our students in pharmacy and pharmacology. And again, this was still supported by the in-house booklet, but this was a total of 6 hours. We also gave a number of ad hoc tutorial sessions as well. But again, the engagement was fairly poor. About 2005, John Kelly, who is actually, I think, online now with us, invited me to give or to assess a PhD thesis over in Galway. And one of the offshoots of that was that we started talking about statistics teaching. Finally, John then invited me over to do those workshops that I was giving at Bath, but to his postgraduate students in Galway. I've been very fortunate that I must have done quite well because he's invited me every year ever since. So I've been going over to Galway for about 14, 15 years now and giving these workshops. Time went on, and then in about 2011, we had a degree scheme review, and it was recognized that we needed to do something extra as far as teaching statistics was concerned. And so I introduced 5 one-hour lectures that were related specifically to the workshops, and I'll mention a bit more detail about those workshops in a little while. The other point about this is that we were delivering this material in the first semester of the student's second year, and it was really trying to prepare them for when they went away on placement in their third year. By the time we got to sort of 2011 to 2015, the degree scheme review for pharmacy had dropped the requirement for statistical teaching. And so we were left with just the pharmacology students, but I then extended this to include natural science students as well. So they managed to get some of the statistics teaching. But notice that while the number of workshops and lectures hadn't changed, we had to move these sessions into the second semester of the second year. And this raises an issue that we found throughout the last sort of 20 years or so, in that timetabling is always a real issue for teaching statistics. It seems as though stats is not seen as a core subject, regardless of the core curriculum from the BPS. And consequently, it seems to be shoehorned into wherever it would fit. Sometimes as a unit in its own right, but sometimes as a bolt-on to an existing unit in pharmacology. It would really depend upon where spare time in the timetable allowed it to go. And that questions the seriousness with which statistics was being viewed at that time. Don't forget, this is 10 years or so ago. A further degree scheme review in about 2015-16 allowed me to actually increase the number of lectures that I gave to the students to about 10 one-hour lectures. And again, I'll summarize those in a little while. We also had a situation where I was unable to deliver the lectures to a second year cohort and could only catch up with these students once they returned after placement. And in order to do so, I crammed these 10 lectures into a 4-week period plus the workshops. And the feedback was surprisingly encouraging. The students could relate from one lecture to the next, and they could see quite easily where each workshop sat in relation to the lectures that I was delivering. As a consequence of that, we ended up moving all the statistics lectures and workshops into the first year, first semester. So as soon as they hit the university, I hit them with a course in statistics. And the results are quite encouraging in that the lectures are quite intensive, they are positioned close to each other, and we get a good take up and a good feedback, good engagement with the students. And in 2018, I increased the student cohort to include the postgraduate MSc in drug discovery students, which started in 2018. So at this time, we're giving 3 2-hour lectures, 3 2-hour workshops and the 10 1-hour lectures. And then for reasons that will become apparent in a little while, I rewrote those lectures over the last summer in 2021. And now I deliver 15 1-hour lectures over a 5 or 6 week period to the first year students in their first semester, still coupled with the 3 2-hour workshops. I want to say something about software. I first started getting really involved in statistics when I was working for YFAS between about 1990 and 1995. YF were heavily Macintosh based, and so the software that I was using primarily was a piece of software called StatView and another piece called Supernova, both produced by Abacus Concepts. I then came to Bath in 1995, and to my horror, I found that Bath University was heavily PC based. But in those days, there was very little transparency between Macintosh and PC software. Luckily enough, StatView was rewritten for the PC in the 1990s, which I was able to use. But then I got involved in using Minitab and SPSS, not only for my own research, but also for teaching students as well. I've already mentioned that I visit Galway every year. And from about 2007 to 2017, John Kelly and co-workers were using SPSS to teach their students as their software program. But in 2018, they started to use GraphPad Prism, and I've been very lucky enough to actually use GraphPad Prism in workshops over in Galway as well. And for that, I'm very much indebted to John and his colleagues in Galway. As far as the workshops are concerned, we've stuck with 3 workshops throughout the last 20 years. These are very simply to cover things like pairwise comparisons for the first workshop, one-way ANOVA for the second workshop, and then in the third workshop, correlation and chi-square. And initially, before the lectures were given as part of the program, I used to try to cover some of the theory in these workshops as well. So not only was it a hands-on in terms of data analysis, but it was also trying to give the students a feel for how these tests actually work and why we use them. Primarily, the workshops here at Bath, we tend to use Minitab and SPSS, but as I've already said, in Galway, I've started to use GraphPad Prism. Also, the workshops in Galway, we started to increase as well. So now I also give workshops on advanced analysis of variance, so looking at repeated measures ANOVA, two-way ANOVA, and mixed ANOVA models, and then trying to argue how best to use post hoc tests and a priori multiple pairwise comparisons as well. And then also I started to look at linear regression for these postgraduate students in Galway, all the time primarily using GraphPad Prism. The lectures have developed over the last 10 years or so. So to start off with, there were simply 5 one-hour lectures, and they were really tied very, very closely to the workshops. But it became very apparent that there was more space to actually give lectures around the surrounding areas, if you like, around the workshops to increase the background information that the students were being presented with, and hopefully engage them even more so with data analysis. I've already mentioned we had a degree scheme review at about 2015, and that gave me the chance to increase the number of lectures to 10. And you can see that we started to expand some of the considerations that we used in these lectures. And then last year, as I said before, I increased these lectures to 15. So we've now got a very good library of lectures that we deliver to these students. So you can see the development over the last 10 years or so in the way in which we're trying to give our students more and more information, but coupled with workshops as well. And that really is probably where we are as far as our strategy is concerned. But we have 3 primary issues with teaching pharmacology, teaching statistics to pharmacology undergraduates. The first of these is student perception. Students are scared of statistics. As soon as I mention the words, they want to run to the hills. And I think really it's because they're worried about the reputation and the experience of statistics, and it's put the students off. And this simply results in difficulty in engagement. They think that they assume that it involves concepts about proving theorems. And this seems to me to relate to their A-level experience, which perhaps is more focused upon pure statistics rather than the application of statistics, which as a pharmacologist, I am more interested in. And of course, this would require a level of mathematical competency. So we have a problem. Are our students focused on applying statistics, or are they still concerned about the pure statistical statistics that they were exposed to at A-level? So pure statistics, it seems to me, is a component of A-level mathematics. And so if your students come to you with A-level maths and they've had exposure to statistics, that's probably on the pure statistics side. In contrast, if they come to you with A-level biology, then they may have some, albeit extremely limited, exposure to the application of statistics. And it's important to bear that in mind when you try to introduce statistics to your undergraduate students. And so the question really remains, when is statistics required in pharmacology education? We didn't really appreciate this. We really tried to make sure that students were prepared before they went away on placement. But if you leave it until the last minute in their penultimate year, teaching is too late, and that's really quite a problem. Staff perception is also an issue. And I don't think that the importance of teaching statistics is fully appreciated by a number of staff, number of pharmacology educators, if you like. this may be simply because they've had a lack of education in their own formative years, and so they've got a lack of knowledge themselves. And you're trying to deal with something which they don't really have a handle on. So that creates problems, particularly in tutorial sessions. It's all very well me standing in the lecture theatre and spouting on about statistics, but if it's not supported by your tutors, then you've got a real problem. Too often, it seems to me, stats is seen as a necessary evil. The other problem is resources. We've got a lack, I think, of experienced educators across the particular industry. We are reliant also on commercially available software, so we're limited to what we can teach by what's available. I generally use these pieces of software: Minitab, SPSS, GraphPad Prism, and there's also the InVivoStat, which is some freeware that's been made available by Simon Bates and Claire Stanford. Also, the supporting literature is not helpful. It seems to me as though the literature falls into two schools. First of all, we've got the mathematical literature, which relies upon pure statistics, which doesn't really help our students. They find it too heavy going. Or we rely upon user guides to particular pieces of software. I use Andy Field's Discovering Statistics using IBM SPSS stats. I've used that since the year 2000 when it was first published, and it's a great book. But at the moment, it's getting on for 1,200 pages long and is costing about £80 and that for an undergraduate student is not really appropriate. So we've been trying to develop resources over the last 20 years. We've got now we believe we've got a good series of lectures that cover the fundamental aspects of descriptive and inferential statistics. And we can apply this and we can teach students both at undergraduate level and at postgraduate level, and even, we could actually extend this to postdoctoral level and early research career pharmacologists as well. To my mind, the focus should be on these three areas: to recognize that there are different types of data. That informs you and allows you to identify the appropriate statistical analysis that you need to perform on your data. And then finally, you then need to be able to correctly interpret the results of the ensuing statistical analysis. We also have some supporting literature that covers the application of statistical methods, but to real data. And this is a bit of an advertising ploy. I do apologise for this, but both Lee and Steve said that I would be able to do this. I have a book that's going to be released, we hope, in the middle of April, entitled Experimental Design and Statistical Analysis for Pharmacology and the Biomedical Sciences, published by Wiley. It's already on pre-release on Amazon, Waterstones and the Wiley websites. And I'm hoping that the predicted cost of about £35 actually comes about. Here are my contact details. If anybody wishes to contact me to discuss this or any other aspects that I've mentioned this afternoon, then please do so, or contact Lee and he'll pass on any questions that you have for me. Finally, later on this year in June, we are planning to run some workshops over a couple of days, both the 13th of June, where we'll be looking at a series of sessions. On the Monday, we'll be looking at basic principles, pairwise comparisons and discussion. That's Monday afternoon. Tuesday, we'll work into more complex, one ANOVA, complex ANOVA, correlation, regression, and chi-square. These, we hope, will be held somewhere in Bath at a location yet to be decided. But it will be great if we can get as many people along to these workshops, which I shall be running along with John Kelly from Galway as well. And that really, I think, is probably all that I have to say. So I'll just leave you with this and any questions.
Excellent. Thank you very much indeed, Paul, for a really fascinating talk. Some really interesting historical perspectives and excellent sort of ways to consider this, and obviously some excellent resources, not only to potentially use, but also to learn new tips and tricks in terms of the workshops. We have about 5 minutes or so for questions. So I will just open the floor for anyone that wants to type questions in, or indeed who wants to just open their mic and speak.
I'll come off sharing the screen now, Steve, as well, because I've had enough of it. Okay, thank you.
Okay, Aidan, you've got your hand up, carry on.
So what we tend to find, and I'm sure we all agree, that students, when it comes to statistics, the only thing they care about is getting p less than 0.05. They don't care how to get it, they just want to see that little asterisk. Do you think it's maybe worthwhile in students to think about describing data in the early stages before worrying about statistics? Because that tends to be where people get really tense.
I think, to answer your question, we need to think about statistics in a very objective and common sense view. Statistics is really there to support what we can really see with our own eyes, which is more of a subjective view, I have to say, but we need some kind of data to support our conclusions, and that's provided by the statistics. We have this really strange value of 0.05%, which Fisher adopted God knows how many years ago, but it was just a kind of a threshold value. And I think we take that far too seriously. And it was never meant by Fisher to take it as seriously as we actually do. And I've got sets of data where I've got a p-value between two groups of, I don't know, 0.045, for example, and I will happily go away and conclude that those two groups are different. Not necessarily. We're dealing with probability. And so there's also a probability, perhaps a bit small, that there is no difference between those two groups. So if I got two groups to give me a p-value of 0.045 and I conclude that those two groups are different, is that any different from the situation where I get a p-value of 0.055 and I conclude that my groups are the same? Are you telling me that the drug-treated groups are different between those two examples? Now, let's use our common sense. Probability, it's a value that we need to look at objectively, realize the limitations of what that is telling us. And I think this is really what David Calhoun was sort of alluding to in his question to me earlier on, that, you know, it's a ballpark. And we need to sort of think about, what does it actually mean in the real world? It simply means that, yeah, okay, there's an indication that perhaps there is a difference between these two groups, but we shouldn't really treat it as gospel, because you can repeat that same experiment the following week and get very similar absolute values in your data. But the spread of the data might be slightly different, or the mean might be slightly off, and you'll get p greater than 0.05. And are the experiments really different? No, I think a common sense objective view as far as the p-value is concerned. Yeah, if you get a p-value less than 1 in 1,000, then yeah, okay, you've probably got pretty strong evidence that there's a difference here. But at the 0.05 level, I think common sense should rule.
Great, thank you so much, Paul.
I think it may be an indicator that further experiments are required.
Yeah.
It's a suggestion that something may be there, but you know, let's look at it again.
Great, thanks for that, Paul. Just one very quick one from the chat before we go to David Calhoun's question. Will there be an e-version of the book? Anne is asking.
Yes.
Yes. Okay.
Slightly cheaper, I believe, than the actual hard copy. But my intention with the hard copy is to actually use that in both lectures and workshops.
Yeah.
I try to incorporate space within the book where students can make their own notes.
Okay.
So if you've got a workshop and you're running that data that's in the book, the students can also make their own notes within the actual hard copy as well. So fantastic. Hopefully it'd be quite useful, both a teaching resource and a learning resource as well, which is the idea. I've already got these lectures available also. So if anybody is interested in those, they should contact me.
That's great. Thanks for that, Paul. We'll circulate your details after this as well. So I see David has his hand up and Menashe's got his hand up. So we'll take those two questions and then I think we'll move on because we've still got lots to get through. So David, do you want to come in? I think you're muted, David.
Thank you. I think I'd know by now, wouldn't you? When I first arrived at UCL, Heinz Schultz gave me the job of teaching 2+2 dose biological assays.
Oh, really?
And that was because I'd written a textbook called Lectures on Biostatistics, which is now free from my blog, actually, if anyone's interested. But the one bit I got completely wrong in that book, well, one bit that I got completely wrong was the interpretation of p-values.
Yeah.
I mean, it turns out if you're in a case where it's appropriate to test a point null hypothesis, that there's zero difference between two groups, that a p-value of 0.05 means that there's, if you seed p equals 0.049 and you claim a discovery on that basis, your chance of being wrong is not 5%, but it's somewhere between 25 and 30%, at least, actually.
Yeah, I do agree with you.
And that's something which students need to know, I think.
Yeah.
And it's easy to do by simulation. That's why I'm so keen on R. I mean, students, apart from statistics, students really should be subjected to some coding. And R is the obvious way to do it because its statistical facilities are very good and it's free.
That's great stuff. And actually, we had a session where Stephen Kelly from Dundee talked a little bit through how he'd used R that ran last week. Wonder if we could circulate further details of that, Lee, just as a reminder.
We've still got the recording from Stephen's session actually, and the plan is to put some of those recordings up on the Brit Farm Stock YouTube channel. So once they're all live on the channel, I'll do another communication to say that people can pick up those older sessions and recordings.
I have a lot of sympathy with David's point of view, but when we're training students who are eventually going to end up in the pharmaceutical industry, when they're hopefully going on to do PhDs, etc., then they are going to be exposed to the commercially available software. And it is what it is, but we need to view the values that are produced by the different tests in the commercial software with a degree of common sense.
Yeah.
I really do think that.
Common sense is something that's trainable, though. Most common sense turns out to be wrong. Just ask Boris.
He's the last person I want to ask.
On that note, we'll take one more question from Nashi, and then we'll move swiftly onwards.
Not sure how I feel about following up on a Boris link. I wanted to ask a practical question, Paul, because I feel confident in teaching the stats that I do as part of my research, and you talked about confidence and competence. So how do you train your staff or your tutors to ensure that there is a consistency and a confidence, or do you do that or not? Because I think otherwise we're not going to get the teaching done if it's just a person like you. So.
And that will involve a massive change in the mindset of some staff members. As I said, a lot of the time statistics is seen as a nuisance and a hindrance to do the next experiment, sort of thing, But if you're going to get your work published, you also need to analyze it properly. And I think that over the last year, 18 months, in the peer review scheme of things, I've probably reviewed something like 10, 15 papers. And I think I've only approved one of those. All the rest were rejected on the basis of either poor experimental design or the inappropriate statistical analysis for the experiments that they were carrying out, or even the inappropriate interpretation of the data that they'd actually got, and so
on a practical level, if we're going to be teaching it, do you at Bath have sort of training to help people be better teachers, or how does it, is it you that does the teaching?
me that does the teaching at the moment. Perhaps I better ask my director of studies whether she wants to get the rest of the staff involved, Dr. Egmead. It's difficult. Most of the time, the staff will take the easy option, you know what's coming, and say, well, I don't know, go and ask Paul. And that's where I get the bangs on the door, sort of saying, please, I've got my final year project to hand in by the middle of next week, but I don't know how to analyze my data. And that's where they come banging on the door asking for help. Whereas I send them back with their tail between their legs and say, well, actually, your supervisor should know how to do this, and you should have discussed this before you did the experiment. So go and do it all again. They don't like that answer. They really don't, you know. Yeah, I see it. We see it in proposed publications. We see it in discussions with other pharmacologists. I see it in our own institution, and I see it across the whole sector, that the skill level for teaching statistics and perhaps knowledge of statistics and how we apply statistics and how we make the right conclusions, even how we identify the correct test to use, is poor. And you're right, we are only going to, I'm not quite sure whether the staff at the moment are beyond help. All right, it's almost as if we've got to start from scratch and we teach the undergraduates to get it right now, and then they can feed on. Because after all, they are the guys that are going to take our place in years to come. They are the guys that are going to work their way up in the pharmaceutical industry in years to come. So if we can get them thinking about things correctly, then hopefully we'll start to make some kind of change, which would be really nice.
Thank you.
Whether it'll happen or not, I don't know.